Hello and welcome back to the beach. Today's session we are looking at regression analysis, and this is the first part of our discussions about regression analysis. There'll be another one straight after this. What I need to do to start with before we get into regression analysis proper is just give you an idea what we're really trying to achieve with these types of sessions. There's a little clutch of these sessions which are going to come together, and what we're going to do is we're going to allow you to have an understanding of forecasting techniques. Now, you've got some sessions on the high-low method. You're now looking at the sessions, looking at linear regression analysis. And then we have some other miscellaneous sessions on time series analysis, and then also index numbers as well, which allow us to see how we can potentially forecast what's going to happen in the future from what's happened in the past. Now, that's a huge assumption. We're assuming that what's happened in the past is a good way of determining what we think should happen in the future. Every single time I say there's an assumption associated with any type of model, it means it's a potential problem. So there's your first problem. We make a big assumption here. And remember, these type of assumptions can cause me some real issues when we try to put these things into practice in the real world. Okay, so let's start off with what actually happens in the real world. We have a situation whereby we look at what's actually happened in terms of actual results or actual data. So we look at actual results or actual data. And what we do is we plot these things together on a graph. And what happens is we're going to have two different axes on my graph, which is going to be the y-axis and then the x-axis. And once we put all these various different points, these data points onto my graph, we can potentially try to assume, and there's my big assumption again, assume that we have a straight line or linear relationship. And the type of things we're looking at here would normally be total levels of production and then total costs. So if you're looking at this from a management accounting perspective, this works out quite nicely. So you can look at total production levels and total costs. And what this now says is we've got a relationship which is expressed graphically and then algebraically through the formula which is y equals a plus bx. OMG, what's he talking about? Right, let's get into a very simple little example and just show you what this now means. So what will happen is we have this type of situation. I've got my little highlighter going, and what we have is this total cost figure up here, which is on my y-axis, which is the one that goes straight up and down. So that shows you the total costs. And then on my x-axis, we've got this production level in units. And what this now does is it allows me to put together what we call a scatter graph, which says, here are the actual data points. So I had a level of production, which was down here, and at that level of production I actually had that level of costs, and then we have other levels of production and other costs associated with those levels of production. This now gives me a scatter graph. This scatter graph will be reviewed, and I'll apply an element of common sense and say, do I think that it looks like there's a relationship? Well, yeah, it does look like there's a relationship because I fudged it to make sure there is a relationship. But in the real world, we'd look at that and go, does it look like it's a relationship? Sort of, maybe. Does it look like it's straight line? Yes, sort of, maybe. But what we have in the real world is this type of scatter graph with these data points. Now what we need to do is try to identify if there is a straight line relationship and how much of the relationship is expressed within that straight line. How we find the straight line is this first part. How we determine the strength of the relationship, that will be my second part. So the first part we're going to do is we're going to look at regression analysis. And what's going to happen here is with regression analysis, it's a statistical technique that tries to show the relationship between two or more variables. And the variables we're looking at here will be total levels of production on my x-axis and total levels of costs on my y-axis. Now, this is usually expressed as a graph and then becomes an algebraic expression. And what this does is it tries to test the relationship and the dependence on these two different variables, if you will, total costs and total levels of production, to see if we do have some sort of element of relationship. Now, if I take my scatter graph from before and then fire in a straight line, you can see that it does appear to have some element of relationship, and I've put the blue line right through the middle of this here to say, hey, look guys, this is where I think the relationship should be. Brilliant, I get that, Ed, that's a wonderful idea. However, how do you find that line and what does it mean? Well, that line is found through the technique that we call regression analysis, and we're going to have a look at the regression formula and actually go through an example to show you how it works. Now, what this line actually tries to show you is down here on the left-hand side, So down here, if I extend this further down, this point here, that is where we get to my fixed costs. So that point there, when we extend that blue line and it crosses the y-axis, there's my fixed costs. Okay, that sort of makes sense because I've seen that type of graph already when I've been looking at my management accounting studies. The variable cost per unit will be the gradient, which is why I show that as that funny little curvy thing. So the gradient of the blue line will be my variable cost per unit. Now we're going to say that my fixed costs becomes A. So my fixed costs will be A. My variable cost per unit will be B. So my fixed cost becomes A. My variable cost per unit becomes B. And then what we have is a regression formula. And this regression formula allows you to calculate the variable cost per unit, which is B, and also the fixed cost, which is A. Now we give you this formula and you look at this formula and go, wibble. So what we need to do is I need to explain to you exactly what these formulas actually are trying to say. So get out your pen and paper, please, guys. Scroll this down. Pause the recording if you need to. Scroll this down, and we're going to go through what all these different things are trying to say. So we have got B. B is my variable cost per unit. So B is my variable cost per unit. N is the number of sets of coordinates or the number of sets of data that we've got. This big squiggly E, so this big squiggly E, this sigma, says sum of. So this thing here where it says sigma xy, that's sum of x multiplied by y. This thing over here is the sum of x multiplied by the sum of y. Okay. Down underneath, we've got number of coordinates multiplied by the sum of x squared minus the sum of x all squared. So you have to work out the x squared on a line-by-line basis, and then we work out the sum of x and then square the whole lot up. Okay. Then A is my fixed costs, and my fixed cost is y, and that y bar, that means it's the mean of y. So that's the average for y, minus B, which we're going to calculate above within this first calculation here, multiplied by the average of x. That's my mean of x. Okay, well, that looks amazingly complicated and convoluted. Let's put it together in an example. Now, what I've done is I've put together this example and I've fudged the numbers to try and show you how this doesn't always work out precisely 100% correctly. So I have got a situation whereby my fixed costs are going to be $10,000. My variable cost per unit is going to be $6 per unit. I know these things because I've understood exactly how my production line works and I've just worked out precisely what these numbers need to be. Then what we've got is 3 different sets of production limits. So we've produced 100 units, 200 units, 300 units. And then what I've done is I've put down my fixed costs and then also my total variable costs. So my total fixed costs stay the same. So that's all okay. My variable cost, $6 per unit, multiplied by the number of units, gives me 600, multiplied by 200, etc., etc. That now gives me my total cost. So that's the cost I would have expected to get. Now what I'm going to do, I'm going to change colours because this gets all funky. Now what happens is we get these actual results. And my actual results are going to be different. So my actual results are never going to be exactly what you would expect to see. And what I've done here, guys, is I've said that at this first set of coordinates, this first level of production, my actual results are slightly less. In the second one, my actual results are slightly more. And then in this third one, they're slightly less as well. But what I've done is I've made the increases and decreases in such a way that the overall totals come out as exactly the same. So the overall totals come out as exactly the same. Okay. Now what we're going to do is we're going to have production in units. This level of production here, this is going to become my X variable. So that becomes my X variable. These actual results, which is my actual cost, they're going to become my Y variable. So they will become my Y variable. So what I can now do is I can put these two things together and say, this is the actual results that we've created from our actual production. We produced 100 units. We had a cost of 10,500. We produced 200 units, 11,350. 300 units, 11,750. That now means we have a total level of production over these 3 different periods of 600 units, and there's my total cost of 33,600. Wonderful. Now what we're going to do is we're going to take these actual results and put them into our regression formula to try and find out what A and B are going to be. Okay, so we've got, this is my X, this is my Y. I'm going to take these values for X and these values for Y, and we've got 3 sets of values for N equals 3. So I'm going to take these values for X, these values for Y, and I'm going to put them into this crazy formula. Okay, what this now does, I've got sum of X multiplied by Y, sum of X, sum of Y. I've got sum of X squared, then sum of X all squared. What I need to do is I need to put this into a table. So I need to know X's and Y's, and I need to know X multiplied by Y, and I need to know X squared things. So what I've done is I've put together this table which shows you how this works. So the data that we've got here for X and for Y, that's the data that we've already seen before. So that's 600 and that 33,600. You've seen those figures already. Now what I've done to find out what XY is, I've just taken the 100 multiplied by the 10,500, 200 multiplied by the 11,350, 300 multiplied by the 11,750. So they just get multiplied across. I then add them down. So that's 6,845,000. That now becomes my overall total, i.e. my sum of XY. So that's where my sums start to come in. There's the big sigma thing kicking in. X squared, I take X of 100, multiply it by itself. That gives me 10,000. 200 squared, 40,000, 300 squared is 90,000. And just to illustrate this a little bit more clearly, we're trying to get to this equation. Remember, I keep on coming back to this equation. I'm focusing on the B equation to start with. With those numbers that we've now got, what I can do is I can say, hang on a minute, these numbers actually show me the sum of these things. So there's sum of X, there's sum of Y, there's sum of XY, and there's sum of X squared. So now what I need to do is I need to take these numbers, these sum of numbers, and put them into my equation. Now remember, my number of sets of data, N, will be 3, because I've got 3 lines of data. So if I now take my regression formula, and my regression formula, as you've seen a million times, it gives you B equals all of this. Wonderful. Now what I'm going to do is I'm going to say B equals, and you can see how this relates back to the previous page. We've got 3 multiplied by, it's 3 because we've got 3 sets of data, multiplied by the sum of XY, 6.845 million, okay, minus sum of X, 600, multiplied by sum of Y, 33,600. That gets divided by 3, which is N, multiplied by the sum of X squared, 140,000, minus the sum of X, 600, all squared. When you crunch that through your calculator, you now get 375,000 over 60,000, which gives me an answer for B, which is slightly off. But it gives me a close approximation for what's going on. And it's that close approximation that we're going to test in the second of these series of lectures. So we're going to look at how strong that relationship is in the second one, in part 2. So 6.25 becomes my variable cost per unit, even though we know it's really 6 because I fudged the numbers at the beginning. Next, what I do is I look to try and find my fixed costs. Now, my fixed costs are A. So A equals the mean, or the average of Y, minus B, which we now know is 6.25, multiplied by the average of X. Okay, so what we have is A equals 33,600, which is the sum of Y, divided by N, because we've got 3 sets of coordinates there. So 33,000 divided by 33,600 divided by 3 gives me the average for Y. 600 divided by 3 gives me the average for X. Multiply that by 6.25. That now gives me A is 11,200 minus 1250, which gives me 9,950, which again is slightly off. The figure we were really looking for was 10,000, not the 9,950. And what this does is it shows you how we can find the variable cost per unit, or the slope of the line, and we can find the fixed cost per unit, or where the line crosses the y-axis, using regression analysis. And what it also shows you is the numbers that it creates are not 100% perfect. So there's a big caveat across all of this. So these things are not 100% perfect. Okay? Now, hopefully that's made sense. If you're not quite sure about any of this, go back and have another look at it, because hopefully it will make a little bit of elements of sense, if nothing else. And make sure you're happy with this before you go into part 2, because part 2 we start looking at Pearsonian coefficient, the correlation coefficient, and we look at the strength of the relationship, which is actually quite an important aspect. But you need to understand this bit first. Okay, that brings me up to the end of this session. Thank you very much for your time and attention here, boys and girls. I look forward to seeing you back on the beach sometime very, very soon. Apart from that, thank you very much and goodbye.